Definition of probability. The probability of an event A in a sample space S is a real number which we call P of A, or probability of A occurring, such that the probability of A is always between 0 and 1 inclusive. So probability all exists on a number line from 0 to 1. If it has a probability of 0, the event is impossible. It cannot happen. There's an even chance if it's at 0.5, that's heads or tails on a coin. And if it will definitely occur, then it is certain and has a probability of 1. Events between 0 and 0.5 are unlikely, and they become more unlikely as we move towards 0. Events between 0.5 and 1 are likely and become more likely as we move towards 1. It should be clear that the probability of S occurring is 1, and that's because every single possible outcome is within the sample space. The probability of the empty event, which consists of none of the outcomes, has to be 0. The probability of a union of disjoint sets is the sum of the probabilities of the events, and we've got an example here to look at. So these are disjoint sets because there's no overlap. So they're disjoint sets, or disjoint events, or the other word for this is they're mutually exclusive events. So if A happens, B cannot happen, and so on. So it can be seen from the Venn diagram that A and B are disjoint, there's no overlap. The probability of A union B is 0.7, and that's just the 0.5 added to the 0.2. The probability of A intersection B is 0, there is no intersection. The probability of A dashed is equal to 1, take away the probability of A, which in this case is 0.5. If we look at that one slightly more generally, so if we have an event A here, which has a probability of occurring of P, then we can state that the probability of A is equal to P. Now, A not occurring is everything else, everything that isn't A. And since we know the probability of S is 1, it follows that the probability of A bar is going to be 1 take away P.